Right, what we're going to look up in this video is what's known as the vector equation of the line. Right, in order to do that, we need to know a particular point on the line. So we've got this particular point here, which is -3, 1. And then to get to a general point on the line, this one here, this generates x, y. Then what I need to do is go from O to A, and then some multiple of a vector parallel to the line. Now the vector parallel to the line I've chosen is 5, 2, because basically I'm going to draw this line here. Okay, so it's like going from O to A, and this is like the first point could be 1 times the value of B, but I can do different values of V. I could do, if I click onto the slider, I could do this one here, which is 1.1, 1.2, and we can see you get a set of points here. 1.3 times V, 1.4 times V, and I get a set of points by changing the value of lambda, the value in front of the vector here. I get a set of points here, generate them, and obviously lambda can take on any value, so I can go all the way this way, and then I can go back, and I can go less than 1, and then I can go the other side, and again I'm getting other points, okay? And obviously the values of the point are from the vector O to R, but OR is the same as doing OA plus AR. If I check this box here, I can see that OR is going to be equal to OA plus lambda times AR, or using the small letters, which is better, R, which stands for XY, the point on the line, is the same as going A plus some multiple of a vector parallel to the line. The vector I chose here was 5, 2. So it will be, this one is, because lambda is negative, obviously it's going in a different direction, and it will be 1.2 times the length of V. But this will generate all the points. So just generate those all again. You can see it will generate all the points. Alright, if I click this box here, I get what's known as, I can see the actual line. Okay, and this is the Cartesian equation, the Cartesian equation. Now normally we will write this in a vector form, so let's just have a look at that. So that's like writing it as R is equal to, in this case, -3, 1, and this stands for a particular point on the line, plus lambda times some vector parallel to the line, which in this case will be the vector 5, 2. And if you look carefully from our particular point that we actually chose, if you go along 5 squares, which is to there, and then you will go up 2, you'll get to the line. So it's going along 5, 2, so it's always parallel to that line. And that's one way. Another way of generating the equation of the line. Now in a later video we will show you how to go from the vector equation here to the Cartesian equation here. What you've got to remember is that R stands for the vector XY, which is going to be the value of this vector from here to here, from O to R. And this is a brief introduction to the vector equation of a line in 2D. However, it's much more powerful, obviously, if we look at it in 3D, which we'll look in the next video.